We use a variation of the police force example to illustrate more of the probability calculations using this time using a probability tree. In a police force, suppose now all you know is this, that 80% of the police officers are male, and 30% of those male officers have been promoted, and 15% of the female officers have been promoted. Now, before we answer any question, it's a good idea to kind of write down what we are given in terms of probabilities. So let's do that here. 80% of the police officers are male, so that means we have probability of male, or the percent of male, is 80%. Now, next it says 30% of the male officers have been promoted. So here you have some kind of conditional probability. If you're a male, chance of promotion is 30%. So we are given a male police officer, and the probability of promotion given a male police officer is 30%. Now, what about the female officers? Given a female officer, chance of promotion is 15%. So promotion given women is equal to 15%. Okay, now we're ready to answer the questions. Question 8 says, what is the probability of promotion for a male officer? So here you're given a male officer and you're looking for the probability of promotion. So here we're looking for a conditional probability of promotion given a male police officer. And oh, guess what? We already have it. We are given 0.3 right here. So this was an easy one. Let's go to number 9. What is the probability a randomly chosen officer is a man who has been promoted? So here, let's see, what are we given? It's a randomly chosen officer. Are we given that this is a man? No, because a man is a part of the question. So we want the probability that it's a man and also the person has been promoted. Looks like we're looking for the joint probability, man and also promoted. We can get this probability just by thinking, just reasoning it out. We know that 80% of the police officers are male, and out of the 80%, 30% of them have been promoted. So we could just multiply the two percentages. As 80% times 30% will be 24%. So that is correct. Now let's do it with a formula. So first, let's talk about how to find the formula. Recall that the formula for the conditional probability, that is probability of B given M was, and then we have the joint probability of B and M. In the denominator, we have the marginal probability. Okay. Now, another way of writing this is, we could say, well, the numerator, if I were to figure out the numerator and I had the other two values, I could multiply the other two values to get the numerator. So to get the joint probability, I could say, well, the other side times the denominator, P of B given M times probability of M. So basically, this is the formula for getting joint probability from multiplying conditional probability and the marginal probability. So that's the same thing we did here. 0.8 is probability of M, and 0.3 comes from probability of promotion given a male officer. Now, in general, it's helpful to draw a tree of probabilities when we compute various probabilities. Let's draw a probability tree. Okay, so what we do is first we start out with the marginal probabilities that are given. So we are given that 80% of the police officers are male. So we could start with a male, female. 80% are male, so male, or men or women. So the probability here is 80%. So the probability of women must be 20%. Now, from these branches, we're going to have conditional probabilities. Conditional probabilities. So here, for instance, now you're given that you have a male officer. And now we talk about the probability that the officer was promoted or not. So it's B for promoted and not promoted. And the same thing for women. Given a woman officer, you could have a promoted woman officer or non-promoted woman officer. Okay, and here we have some probabilities we could use, 30% and 15%. So conditional probability here is 30%. So that is probability of B given M. And now this, of course, is going to be 0.70 because it's a complement. And here we're given B given W is 0.15, and the other must be 0.85. Okay, so here's a list of the probabilities summarized in a tree. From this, we could get the joint probabilities. So here we're going to have joint probability of M and B. Then we have joint probability of M and complement of B, M and complement of B, and so forth. Okay, so here we multiply 0.8 and 0.3 to get 0.24. Here we multiply 0.8 and 0.7 to get 0.56. Here is 0.2 times 0.15, giving us 0.03, and the other is 0.2 times 0.85, giving us 0.17. So here's a list of the joint probabilities. So again, start with marginal probabilities, and then we have conditional probabilities. Then we get the joint probabilities by multiplying the marginal probability and the conditional probability. So starting from here, multiply this to get the joint probability at the end. If you were to add up the joint probabilities, you will see they sum to 1. So that makes sense. Once you have all these numbers, it's easy to get all kinds of probabilities. Notice that this expression is the same as multiplication of probability of M and the probability of B given M. So right here. Okay. Now let's talk about question number 10. What if an officer has been promoted? What is the probability this person is a woman? So we want to know. Now we are given the officer has been promoted, so we are given B. We want to know the probability the person is a woman. So it's probability of let's see, W given B. The probability of W given B. So now we could write this as P of W and B. Then divide this by probability of what? Oh, this one. Probability of promotion P of B. Okay, well, let's take a look. P of W and B is, oh, now we have it. We must have, oh, right here, 0.03. 0.03. Now, probability of B is, let's see, it should be, there's two ways. You could be a man and be promoted, or you could be a woman and be promoted. So you could add up these probabilities. You could be a woman and promoted, and then, or you could be a man and be promoted. Okay. Now, probability of women and promoted, that's 0.03. Probability of man and promoted, that we got over here as 0.24. So the sum will be 0.27. Okay, now we have the numerator and denominator. Numerator we have 0.03. Denominator we have 0.27, and this gives us 0.111. 111 is the answer. Now let's go to question 11. Question 11. What percentage of the promoted officers are male? What percentage of the promoted officers are male? So let's see. Now here, again, what kind of probability is this? What percentage of promoted officers? So we want the probability of what? Of the male. What percentage are male? What percentage are male? And are we given something? Oh, promoted. So out of the promoted officers, and so this is a given condition that's given promoted officers. Out of this, what percentage are male? So this part is the unknown. We want the probability of male. So we would write it as P of M given B. P of M given B, and again we could use the conditional probability formula, M and B in the numerator and B in the denominator. Okay, now we have these results right from before. P of M and B, P of M and B was, oh, that's over here, 0.24, and P of B was 0.27. So that is 0.889. Also notice that, well, this M given B must be a complement of W given B. So actually we could have solved it like this. We could have said, well, it's just 1 minus probability of women given promoted, which was 0.111, and that leads to the same result as 0.889.